In the circle below, U is the center, Vx is a diameter, and the arc VW equals 110 degrees. Use this information to fill in the blanks. And I added in this circle over here as just kind of a reference. So first, an inscribed angle. What is an inscribed angle? Well, it's an angle, excuse me, with its vertex on the circle and its sides contained as chords. So I'll draw that out. And once again, it's an angle with its vertex on the circle. So that means its vertex has to lie somewhere on the circle, and the sides of the angle are contained as chords. So this, we could say that this is a, oh, hold up. Oh, there we go. We could say that this is an inscribed angle. Just anywhere where this vertex here is touching the circle. Okay, so we could say, if we're looking back over at our circle, we could say that angle X, V, Y. Angle XVY is an inscribed angle. Next, give a minor arc. Once again, what is a minor arc? Well, there's a couple different things we think of when we think of arcs. We think of minor arc, we think of semicircle, and we think of major arc. And if I were to just draw this in there, okay, I'm going to draw two different colors here. I'm going to go blue. And then I'm going to go green. These individual little sections here, okay, if this was a point and this was a point, which one do we think would be the minor arc? Which one do we think would be the major arc? Right, the smaller one would be the minor arc. And we say a minor arc is any arc length that's less than 180 degrees. So if we look at our circle, is there any arc length that we see that we know for sure is less than 180 degrees? Yeah, from V to W, because it's only 110 degrees. So we could say that VW. And to show that it's an arc, draw that thing over the top like that. Next, give a semicircle. Well, if a minor arc has to be less than 180 degrees, and a major arc has got to be greater than 180 degrees, a semicircle is an arc length that's exactly 180 degrees. Or we could think of it as an arc that's cut by our diameter, or an arc whose endpoints are the diameter. So our diameter here is Vx, so the arc from V to X, or let's call this one, since that W is in the middle there, let's call that arc VWX. And once again, since it's an arc, make sure we have that arc over the top. So VWX, since Vx is our diameter, we know that the arc length VWX is going to be a semicircle. Next, find the measure of VUW. Okay, so VUW, that looks like we are given that angle that's kind of in the middle of our circle there, or we can call that our central angle. And because it's our central angle, that angle is going to be equal to the arc, the angle of the arc. So since the angle of that arc is 110 degrees, VUW is also going to be 110 degrees. Next, find VYW. So let's say this was, so that means we want to find from here all the way to here. Well, let's think. How many total degrees are there in a circle? All around the circle adds up to 360 degrees. I'll scroll down here a little bit. All right. Well, what's the section that we know? Well, we know that little section there, the remaining section that's not in that highlighted red part there, is 110 degrees. So if we take 360 and subtract out 110, whoops, shouldn't we get the remaining of VYW? Yeah. So we should get, after subtracting here, 250 degrees. Next, give an inscribed angle. Once again, an angle with its vertex on the circle and its sides contained as chords. So we could say that the angle, let's go QST. As our inscribed angle. Give a minor arc. Once again, a minor arc is an arc degree that is less than 180. So we could say that the arc QR is a minor arc. Excuse my handwriting here. Give a semicircle. Once again, that's an arc degree measure. That's exactly 180 degrees. Or that's cut by the diameter. So we could say that QS, the arc QRS, QRS is a semicircle. QTS, well, let's look at that again. QTS, isn't that also an arc that is cut by the diameter? Yep, so we know that that's going to be 180 degrees. And then finally find QPR. QPR, that would be this angle right here. Well, and since it's a central angle, right, QPR is what we call a central angle. That central angle is going to be equal to the intercepted arc. Well, and since our intercepted arc is 110, our central angle is also going to be 110 degrees.